last but not least, we're going to go through the midpoint formula. The midpoint formula is actually quite easy, and it's really revisiting something you did last year, just like the distance formula, except that this one's actually even easier. And the midpoint formula is a formula given to you if you have a line segment in a coordinate system, which I'm going to draw right now. With given coordinates, and we want to find the midpoint, the exact coordinates of the midpoint of that segment. So here I have A, and here I have B. And as I did before, I'm defining its coordinates. I'm saying A, here's x1, and B has x2, and the y coordinate is y1 and y2. I'm drawing my segment between A and B, and in the middle of that segment, I'm going to put point M, because that is my midpoint. I want to find out what is the midpoint of that segment. I want to know what are the coordinates, and how do I find that? Well, very much like we did with the Pythagorean theorem, we're going to see that the y's, if you look at the y, y2 ends up here, y1 ends up here, because those are the vertical coordinates. And similarly, you're going to see that x1 is down here and x2 is over here. And essentially, that midpoint M cuts exactly in between y2 and y1 and x2 and x1. And in fact, the x coordinate is equal to the average, x1 plus x2 divided by 2. And this coordinate is equal to, the y coordinate is equal to y1 plus y2 divided by 2. It's exactly the average between these coordinates. And so it's fairly easy to show that the midpoint formula is just an equation for a point. It is saying the x coordinate is x1 plus x2 of the two existing points A and B averaged or divided by 2, and the y coordinate y1 plus y2 divided by 2. So that midpoint can be used many different ways. But let's just try a simple problem and look at example number, I believe it's number 3. And they're just going to give us 2 points and say find the midpoint. So -1, -3 as the first point. Oh, sorry, -2. -1, -2. And the second one is 3, -4. So my midpoint is -1 plus 3 divided by 2, -4 plus -2 divided by 2. -1 plus 3 divided by 2, so this is 2 divided by 2 is 1. -4 plus 9 is -6 divided by 2 is -3. So my midpoint between those 2 points is 1, -3. The very last problem in 11.5, in fact, the very last problem in the chapter, is a problem that combines both the midpoint and the distance formula. And it's a longish problem, and so I'll do my best with it, knowing that it's bittersweet because it involves Washington, D.C. And I know you missed that trip, unfortunately. All right. So say when you do get to D.C., and hopefully with some good friends, and again, let me just label this, so if you want to look it up in your book, you can. I'm looking at example 4, and it's called Solve a Real World Problem. In fact, all that they've done is that they've sort of done a grid of Washington, D.C., and I'm not going to try to, well, I guess I better have to recreate some of this grid. So let me draw my axes. X and Y. And I am told that the White House, which is known as point A, is at point 0.18, it looks like. So 1, 2, 3, 4, 5, 6, 7, 8. Let me just count again. 1, 2, 3, 4, 5, 6, 7, 8. I'm counting in your book in case you're wondering where. So here's A, which is the White House. I'm going to define what that is. So that White House is at 1, 8. And then point B is at 2, 2. And that's right here. And point B, which is at 2, 2, is the Washington Monument. Moving down, let's see, 3, 4, 5, 6, 7. Point D is at 7, 1. I'll come back to C. And point D is the Smithsonian. So 1, 2, 3, 4, 5, 6, 7. And 7, 1. This was B, this is D, and that's the Smithsonian. If I go up from there, up 2 at C, so that's at the point 7, 3. I'm at the Natural History Museum. I'm abbreviating. And then I'm left with E and F. So F looks like it's at the same height as A. Sorry, E is at the same height as A, so it's 8. And the Y coordinate is going to be at 9, I think. So it looks like it's at 9, 8. 8, 9. So 9, 8. That's going to be point E. And point E is the National Portrait Gallery. And then the last point, which is point F, is the National Gallery of Art. So this is at 9, 10, 11, I believe. Yep. It's at 11 at the same height as C. So 10, 11, and here is my point F at 11, 3. And that is the National Gallery of Art. Okay, so you're in Washington, D.C. These are all the sites that you are looking at visiting. You want to meet at the landmark that is closest to the midpoint of all your locations. So at which landmark should you meet? So you and your friend are visiting. So you are at the National Gallery of Art. So let's put you, so this is you, the National Gallery of Art. And your friend, it says, let's see, you're the national, and your friend is the Washington Monument. So that was B, right? So Washington Monument, this is your friend. So that's where you are now. So let's reread this. You and your friend are sightseeing in DC. You're at the National Gallery of Art. Your friend is at the Washington Monument. So you are at B and your friend is at F. You want to meet at the landmark that is closest to the midpoint of your locations. At what landmark should you meet? Okay, well, in order to figure that out, your first job is to find the midpoint of your location, right? So how are we going to find the midpoint? Well, the midpoint is going to be, do we remember the equation? I should have done that in black, so I'm going to switch to black. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So the midpoint of the two locations, and I'll circle them so it's a little bit more obvious. F and B, right? What's the midpoint between those two? That's what we're trying to figure out. Well, if we plug in those values, you have, and we're dealing with the points, let's just write them up here, 2, 2, and 11, 3. So x1 plus x2 is 2 plus 11. We divide those by 2. And the y's are 2 plus 3. We divide those by 2. And so the midpoint is going to be 2 plus 11 is 13 divided by 2 is going to give 6.5. And this is going to be 5/2 or 2.5. So we found the midpoint. And 6.5 and 2.5 is our new point. The next question is, you want to meet at the landmark that is closest to that. And so the two closest are C and D. Now I've drawn it so C looks closer, but that's not necessarily true. So we need to figure out which is closer to 6.5, 2.5, C or D. Is the Smithsonian the best place to meet, or is the Natural History Museum the best place to meet? Well, we have to do basically two distance formulas. For point C, the distance formula equals, I'm going to use a thin marker for this, I believe. No, it's going to look really off if I do that. Okay. The square root of x2 minus x1. So I'm going from the midpoint, right? So this is my first point, 2 point C. So that's going to be 0.7 minus 6.5 squared, the difference of those x's squared, plus 3 minus 2.5 squared. So my distance from C, the Natural History Museum, when I work that out, is going to give me 0.71 units. So the map is telling me that's how close I'll be to C. When I'm at the midpoint between them, that's how close I'll be to C. Let's see what that looks like for D. So if I go to the Smithsonian, what's my distance looking like? Well, here I have D equals, and again, I'm using my midpoint, right? I'm looking at the distance between the midpoint and the Smithsonian. So that's going to be 7 minus 6.5 squared plus 1 minus 2.5 squared. When I solve for D, and I do this all out, I'm going to end up with about 1.58 units. So what that tells me is when I get to this midpoint, my midpoint between our current locations, the closest place is going to be the Natural History Museum. So your answer is we should meet at the Natural History Museum, because that is point C. All right, well, that was a cool use of both formulas and a good way to end the chapter. Tomorrow I'm going to do a review, and the next day you'll have your test. This is not a hard chapter. I expect you to do quite well on it. Please make sure that you ask questions if there's anything in this that's confusing you.